slideshow. Yeah.
All right. Thank you all for coming. Week 7. Hope it's all going well. Quick announcement. No meeting next week. I'm pretty sure like nobody would be here Wednesday night, so we're not going to do it. So after this meeting, we'll see you in 2 weeks. And yeah,
Thanksgiving.
Yeah, have a good Thanksgiving and everything. Just a little quick update on the progress. Give it off to Sebastian.
Yeah. So this is kind of what the website's looking like right now. Y'all did a great job on this last week. We had this initial interface, we put it in React, and I guess, yeah. And then recently, I guess this week, we went into the login. I think Will worked on the login page and with Clerk. Shout out to Will. Basically, we can log in now with OAuth and like your own email address if you'd like. And it'll show your profile picture, which is really nice. If that worked, okay. But
I think it's the redirect. But
anyways,
that can be fixed.
That's fine. Yeah. Basically, we just got login implemented. I think our goal right now for the front end team at least is to try and get that chat page like initial layout onto the website. Let me go back. It's just not running. Okay. That's probably why. Makes sense. Let me just quickly run it. All right. Cool. So yeah, you can see I'm logged in now. You have your little profile picture. All done with Clerk, which is really nice. So yeah, trying to get this chatting page is probably what we want to focus on on the front end team, along with maybe working on, I guess, getting images in these boxes and yeah, any other design things we want to do. And then for the back end team, I guess I need to talk with you guys, or we need to talk with you guys just on I guess how we're getting the user from Clerk and how we're going to like make chat, like I guess chat messages happen correlating with users. Anyway, we can talk more about that later. And then AI team, I guess our plans for that, Tom is going to give you a talk on I guess the Q&A, I guess the aspect of it. That'll be when we split up into teams. And then yeah, that's about it. That's for our progress. Okay. So yeah. Let's just ready to split up into teams. Yeah. Okay. So yeah, you guys are already split up, so there's no splitting up, but I guess Tom is going to go to the AI team. I can talk with the backend team and the front end team. Hopefully we can start collaborating between those two. Yeah.
Do you guys want to learn about like the AI tools that we're going to use in the AI team just for fun?
I do. You do.
Okay. You guys, is AI like interesting?
Okay. So you want to prevent that?
Yeah, I could just do like a full presentation.
Okay,
so.
Here, let me
Thank you.
That. Make sure to screen share. I'll stop sharing my screen. Oh. Hey, Carson.
Cool. So we're gonna this latency.
You want to like turn on your camera as well?
Yeah, could you turn yours off?
Yeah.
Hey, people on Zoom. So I'm just gonna give like a little presentation.
I think you're
Hey, people. So yeah, I'm gonna give a presentation on LinkedIn AI and basically how we can use that in our project. I have this drawing up. So let's see. I don't actually know where it went. Let me load it. Load from file. AI design.
Do you want to turn on your camera too? All right.
Sure. I have so many tabs open. Cool. So I don't know where my design is. Oh, I have a virtual background. Nice. Okay, so this is just like SkellyDraw. It's usually what I use for like system design stuff. I also like Draw.io, but yeah. So I did a little. So before we like start it, I kind of want to talk about like our system design, at least on the AI side. This will help not only the backend team, not only the front end team, but really everyone, so that we can understand like how we're actually going to build this app. So as we know, we're building a chatbot on OSU course data, syllabi, really miscellaneous course information. Really, whatever you have for your course, you give it to the bot, and it can make intelligent responses. So in this case, we start at the PDF. That's all the way over here. We see this PDF icon, and we're using LangChain, which is essentially like a tool chain that allows us to do multiple things. In this case, what we're going to be using it for is grabbing our PDFs and turning it into an array of documents. So a document is just, it could be really anything, text, really any unstructured data, but we're going to split them into documents. And then once we do that with documents, what we can do is actually pass it over to OpenAI. And traditionally with embeddings and embeddings in general, you would just store it on like your local machine. So you would run the model and store it on the local machine. However, with OpenAI, we can actually use the power of like the cloud with something called Pinecone. So Pinecone is a vector database which is stored in the cloud. And instead of storing our embeddings locally, we take those embeddings, and once again, an embedding is just a vector or an array of numbers, if you guys have taken like data structures. And with those vectors and array of numbers, what we can do is actually store it in the cloud. And then let's say we have a question. Our question in this case would be like, what course is this? This turns it into an embedding, which is just an array of numbers. So like the semantic meaning, what does this mean? So what course is this would be like an array of numbers. And then we use OpenAI to do that. After that, it calculates a similarity score. So this similarity score is given from the existing embeddings. So that's why we have this stored in the database in the cloud. So it basically compares that and then gets a similarity score. With that similarity score, what we can do is actually use OpenAI. So as we've all used ChatGPT, OpenAI, they provide like a series of LLMs. And that just essentially allows you to have natural language processing. So essentially, if we ask something that's like human looking, it can give us a human looking response. So what we do is combine those, and then that of course gives us a response. And it's super high level in this like system design, but I really want to show you guys this because it helps clarify like certain things that seem ambiguous at first. So in our case, the AI team we already have a bunch of PDFs, which is stored in GitHub. In this case, what we got to do is convert those PDFs into documents. Once we have those as documents, we store it in Pinecone. Once we store in Pinecone, we can ask it a question and just use all that stuff from earlier to get a response. And yeah, so I currently actually already kind of did that. We're using something called Fast API for the front end or for the AI team. Let me go back here. App Club, Beavs.ai. Actually, I could just do this. Repositories. So in the front end, or the AI team, excuse me. So we currently have like a server, right? And then in our server, there's only one endpoint besides hello world. And this is just a file upload. So this begins like the process where you actually like upload the file. This begins, we store it in like the data syllabi and then the file name itself. So this is how we of course do that first step in our system design. We'll have a bunch of PDFs. Next, that's where we can use LangChain. So I currently actually already have it locally, so we can just go into that. Let's see. Or actually I made a draft PR, so we can look there. But in this draft PR, what you're gonna see is me doing like a, essentially like a mock-up of document Q&A. So here, I even like put like a description. I'll release this PR soon for you guys. So if we go down here, we can go to the commit where I did document search and LMMQA. So we can start at the top. This is of course LangChain. They provide a bunch of tools for us to help make building AI applications easier. So we load our environment variables. Here, this is just the standard stuff that we need. Remember, we get like an OpenAI key. We're gonna provide this for everyone. This is AI team. And then Pinecone key and then environment. These are of course provided from the cloud infrastructure. And then we start with loading the PDF. So in this case, you can see that I take the unstructured PDF and just load it. Then I call a method on that. And then after we load it, we can actually see the number of characters in the document. And then what I can do is actually chunk the data into smaller pieces. So remember from our system design, what we're doing is just turning these documents into smaller, easier, fine-grained embeddings. So that's just an array of numbers. And see how OpenAI actually provides that for us. Now we just initialize Pinecone. And then in this case, the PDF is CS161. So what we're doing is calling that index CS161. And that brings up the next point. So you can see how this grows over time. We'll have different indexes for different classes. So let's say you have a class like CS370, all the data for security is in that index. And over time, it gets more intelligent and it has more documents to search through. And then here, what we're doing is just searching for the document from Pinecone. Remember, this is a database in the cloud, so it provides methods that are super easy for us to use. And then this is finally the query. So I just ask it, who's the instructors for this course? It does that similarity search. Remember from our system design, the similarity search, similarity score, gets that score. And then of course, this is where we use OpenAI. This is where we use like the LLM, the ChatGPT to actually get a response. And once we do that, we can just print that response. And now I'm going to show you guys actually working locally because there's no fun in just showing the code. So if I get checkout, I already made a branch for it. So it's called DB. Actually, let me list my branches. Okay, it looks like it's called document Q&A. So if you just check out document QA. Cool. So now if we just go here, and then if I ls server specifically, okay, let's go into the server. And then if I run this file, so Python 3 lib.py. So remember what I said earlier. This is basically in the background. It's taking those documents, it's loading the PDF, it's splitting them up into chunks, which we can of course give to OpenAI. And then OpenAI is able to make intelligent responses based on that data. Because of course, if we just gave it the entire PDF in one query, it's not only not efficient, but OpenAI won't let us do that. So what we do is split it up, and then based on our text, we can get a response. Oh, it looked like my capacity just reached successfully split, but you can see this first part. So we have 2,000 characters or 20,000 characters in the document, and then we split it up into 23 documents. And then this is just because I'm using a single index because I'm using the free tier. But if I just change the code really quick, what I can do is actually just change this back to what the existing one is called. So it's lang chain 2. And then if I run it again, this will, and then just to recall, let's go back to the code. So in this document, I asked, well, who are the instructors for this course? So I asked who the instructors are for this course. If we go to CS 161, we should get something saying these 3 professors. So if we go back, we see that our code's running again. Let me make the output a little bit bigger. And of course, this is like the longest part of the process, loading the PDF, splitting the documents. So this is why we have like an API server, which kind of encapsulates that away so you don't have to see that. Oh, I'm getting X is not defined. We love live coding because there's always errors, right? LM response, docs query. Who are the most instructors? Oh, I see X. Let me see LLM. Oops. Oh, my laptop is about to die too as well. Okay, this should work now. Yeah, so once again, the question that we're asking is who are the instructors for this course? The index is called langchain 2, but this would be ideally called CS 161. And then, yeah. And then remember, this is all in the cloud. The only big parts that we're doing is the parts that take a long time, which is loading the PDF. However, if we load all of these prematurely, we don't have to like do that every time. So if we go back here, we split the documents, 23,000 characters into 23 documents, so it's easier to search for. And now we get that response. So it's actually giving us data from that PDF document. So exactly, remember when I said it should match something from here? So Zhang, Baker, and Hidu. And then we of course see that here. So this is like a very abstracted high level approach of like what we should do. It's in one file. It's super like buggy as well. But this is kind of like what we want to do, at least on the AI side. And I really hope that it helps not only the front end or back end team, but really just all of us understand like the type of app we're trying to build. And yeah, that's it for the AI part of our app. And then there's a question. Yeah, so because we're only using the free tier, that's like a problem. But luckily, OCU Engineering provides us with a decent amount of funding. So yeah, we can pretty much put as much money in this as we want. But yeah, any other questions?
So just to clarify, the reason we're splitting the PDFs is because OpenAI doesn't allow such a big, I guess what, if you could clarify what the reasoning behind splitting.
Yeah, so let's go back to our system design. So whenever you think about like what's actually splitting the text, that's langchain. Okay. So OpenAI is just taking that text and then making a natural response to it. So like a human-like response. Okay. And OpenAI, since it's of course a service that we don't create ourselves, they have like limits. So yeah, if we just gave it all of the text in like a single document, it wouldn't be able to do that. So that's why we need to actually find the similar document first, using something like Pinecone, and then we're actually able to make a query. Yeah, it basically just shortens our solution space because it would just kind of think of it like a data structure almost. You don't want to search like the entire array if the element's like at the very front, you know? So yeah.
How does it go about splitting the document? Like, is it just like go after a certain number of lines?
Yeah, great question. So if we actually look it up right now, OpenAI provides something called text ADA embedding and then O2. So this is just an embedding that they provide. And that's actually it's new and improved according to them. So yeah, this is just, you know, like a model is. Yeah, a model is just basically a series of like data and like algorithms to execute on that data. So in this case, they have an embeddings model, which converts unstructured text into numbers. So you can see on the right here, see how there's like a bunch of numbers almost in like a vector, an array. So what they do is they actually split the text. So you can kind of see that. So they take natural language text, they put it in the model, and then it outputs a vector. And then because we have a vector, we can compare it to other vectors. And then that's how we're able to get like a similarity score from the system design. So yeah, that's pretty much how we split it.
Wait, so, turning PDFs into embeddings and loading them as vectors, does LangChain do that for us?
LangChain does the document part where we actually split it, but it doesn't do the embedding part. So that's where we get OpenAI.
Into vectors, we do ourselves?
Not necessarily ourselves, but we do it programmatically with OpenAI's toolkit. So if you want to look specifically in this line of code right here. So if you look right here, well, we can see that Pinecone is actually getting all the documents that are similar to what, not only our text, but it uses that embeddings.
Okay, and
then this is how we get that score from the vector. And then here, remember how it's a vector.
but like how are the embeddings stored in the database? Like,
Oh, I see. That's a great question. ChatGPT. So if we go to Pinecone, we can actually see once we go into my free tier database, this is of course like a cloud database, kind of like MongoDB, Atlas. So you can see like the text, this is the raw text. This is it represented as a vector.
Okay.
So we just search. So this is technically like this is the entire PDF, but we're just searching specifically for one part. So if we asked a question, for instance, like let's say we asked, what are some of the things I'm going to learn in this course? It'll probably look here because this says things like the learning outcomes of the course. So that's what it will look for. And then it'll extract this single document. And then that's what we'll query for OpenAI. Does that make more sense?
Yeah.
Cool. But yeah, we're going to actually provide all this infrastructure. I just used a free tier to kind of show you guys like as a test. But yeah, we'll eventually have like multiple indexes for each course, ideally. Probably like, let's see in the document, there's like what, 60 classes? Not even like 30 classes. So yeah, we'll probably have like 30 indexes.
I have another question. Are we using the database that we made or the one that we already got added to?
We're gonna use the one that we got added to, but the only bad thing about the one we got added to is that we only can have one index. So like one course, one, etc. So we're gonna actually put some funding into that so that we can have as many as we want. And yeah, that just has to go through like bureaucracy with like OSU getting approvals and stuff. But it'll happen soon. Does anyone have any other questions? Taz?
Is it more accurate the more embeddings you have, like for one PDF?
Yeah. So more embeddings. The only bad thing about having too many embeddings is that sometimes you could sacrifice like accuracy for like fine grayness. So yeah, like if we had like 80 like 1,000 embeddings, it could be hard for like, let's say a lot of data that's similar to each other.
Yeah.
But yeah. Any other questions? Sick. I'll PR this and let the AI team go at it, but we'll talk about that. Yeah, you guys can get back to your teamwork.
Open or for ChatGPT Plus.